Hello, welcome back to Chapter 5, Section 1. We're talking about transformations of quadratic functions. In this video, we're going to talk about translations. You've learned this before when we talked about transforming absolute value functions. And there was also a section where we talked about transforming linear functions. Usually we skip the transforming linear functions. So all of this you've seen before. We've just now we're going to see it with the quadratic function. So let's talk about what this is. The rule for horizontal translations is that if I have f of x, so f of x is where I'm going to start, whatever f of x is. My new function g of x is going to have all the same steps of f of x, except I'm going to replace the x with x subtract h. Remember that this is a subtraction. And it goes to that idea of it's kind of the reverse of what you would expect. When we deal with horizontal transformations, all of them, the reflections, stretches, compressions that'll come up in the next video, we replace the x with something, and it's usually backwards from what we would expect. So if we think that if we see that h is positive, it's going to go to the right, but you'll see x subtract a number. So like if h is 3, it'll say x subtract 3. You are subtracting negative 3. If h is already negative, it'll go to the left, but subtracting a negative will look like x plus something. So if it's negative 7, it'll say x plus positive 7. Remember that. You'll see me do that a lot, but try to remember that everything's backwards when we do horizontal stuff. For the vertical stuff, again, f of x is where we're going to start, but the vertical stuff is what I want. G of x is going to, this one changed the input, this is going to change the output, the entire f of x. So I'm just going to add whatever k is to it. And if k is positive, it goes up, and if k is negative, it goes down. Now I am going to grab an iPad for a second, and I'm going to show you this. And I'm using the Desmos on the iPad, and yes, I'm recording my iPad with my iPad, okay? Instead of just switching the screen, that way it looks, I'm trying to make this look like what you would see. I've already typed these in. I'll get to this in just a moment. This is what these things are going to look like. But I'm going to show you, I don't know why that did that. I'm going to show you what the actual translations look like. So I've got it set up now to where h is 0 and k is 0. Okay? So in other words, it is not, subtracting 0 doesn't change anything, adding 0 doesn't change anything. So right now this is the same as y equals x to the second power. Right? So here's the blue one that I'm going to show you, and this is the red one. The red one is the actual parent function that I talked about in the previous video, y equals x squared. I'm going to leave that one alone, but I'm going to mess with the other one. Let's first change it into a translation. If I move it to the right, the blue graph moved over to the right. So now my h is 5.1. I tried to get it 5, but it wasn't exactly 5. Don't worry about that. This is x subtract 5.1. I left my k alone. I haven't done anything with that yet. If I go back and I make h negative, we'll say negative 7.2, it translated to the left from the original. I know you saw it slide to the left, but from the original, the parent function, this is to the left. Subtracting negative 7.2 is going to look like x plus 7.2. Remember that. Okay, so that takes care of that. I'll try to put this back to 0 if I can. Oh. Never lets me do that right away. Okay, there we go. Got it. Now watch what happens when I do the translating up and down. So now I'm going to change to the k. That slides the blue graph up, and this slides it down. But remember, I'm adding k, so when I add a negative number, that looks like subtraction. So that's really what's happening here. So let's describe the transformations, and then we will see if we can sketch a graph. And I think that for these, it's usually best if I also draw not only the function I'm supposed to draw, but it's also good if I draw the parent function from where I start. All right, so what are the transformations? Notice I've got parentheses. Here's something that's going to be true no matter what. If you see parentheses, that means you have a horizontal transformation. Now for these, we're only dealing with slides, translations. Later, with reflections and stretches, compressions, if you see parentheses, that means that there's going to be something where you're moving it horizontally. I have parentheses in both these examples, so there's going to be a horizontal part. So first, I got to figure out what the x plus 3 means. This is a horizontal translation. Now, what do I subtract? Because remember, it's x subtract h. What do I subtract that looks like adding 3? If I subtract negative 3, so like if I do x subtract negative 3, that's going to look like x plus 3. So it's a horizontal translation to the left 3. The plus 1 on the outside tells me that I have a vertical translation. And since it's on the outside and it's vertical, things behave. They act the way you think they should act. So when I see plus 1, that tells me that it's up 1. All right, so now let's try to draw the graph. I don't care which color. I've got a green Sharpie too. I like that color. It's kind of a cool color. So I'm going to draw the original parent function. Remember, my original parent function uses the perfect squares. So my parent function is y equals x squared. So that's 0 squared, 1 squared is 1, 2 squared is 4, and 3 squared would be 9, which would be up here someplace. But not only that, but I've got negative. So negative 1 times negative 1 is also positive 1. And negative 2 times negative 2 is positive 4. And for the parent function, it's going to look like this. All right? And I'm going to identify that as the parent. Now, how do I draw the translation? Well, look at that vertex. This is going to be important. That vertex is going to move left 3 spaces. So it's going to go 1, 2, 3. But it's also going to go up 1 space. So it's going to go 1, 2, 3, up 1 space. Now, all the other points are going to do the same thing. This point, 1, 1, is going to go 1, 2, 3, up 1, right here. This point, 2, 4, is going to go 1, 2, 3 to the left and up 1. Right here, negative 1, 1 is going to go 1, 2, 3, up 1. And I didn't make it that thick, but right here at negative 2, 4, it's going to go 1, 2, 3, up 1. So here's my function, or at least as much of it as I can see. It's gone left 3, excuse me, and up 1. And all the points on the graph go left 3 spaces and up 1 space. All right, let's try the second one. So again, I have parentheses. That means there's a horizontal transformation. It's x subtract 2, so my h is 2. This is a horizontal translation to the right 2. excuse me. And the subtract 1 on the outside tells me that I have a vertical translation. Negative 1 says down, so down 1. So again, I'm going to start by drawing my parent function. And I still know what those are. 2, 4, negative 2, 4, and my parent function looks like this. Might make those dots just a little bit better because I'm going to need to point to them later. I accidentally made that too sharp. That's okay. All right, now let's move everything. Let's start at the origin. I'm going to go to the right 2 spaces and down 1. So I'm going to go right 2 spaces, down 1. That's my new origin. Sorry, excuse me, my new vertex. It was at the origin, that's where I screwed up. But my new vertex is right here. This point, 1, 1. Right 2, down 1. 2, 4 is going to go right 2, down 1, right here. Negative 1, 1 goes right 2, down 1, and it's right there. And then negative 2, 4 goes right 2, down 1. That's going to be right there. And I think I have enough that I can draw this. Again, no arrows. And make sure you draw it all the way. Don't stop it in the middle of the graph. Okay, that takes care of the translations. We're going to come back and talk about reflections and stretches and compressions, which is going to be a little bit more difficult. Please make sure that you have Desmos handy when you're doing these problems so that you can look and see what it actually looks like and see if you got the right idea. Use Desmos as a way of checking your work. See you in the next video.